Let me share my screen. So we were discussing about Docker Compose. So let me show you how to install Docker Compose. We know how to install Docker Compose, we have seen. And why we are discussing about this Docker Compose and all, we were discussing about the methods of creating multi-container architecture. We are now discussing about the topic called multi-container architecture in Docker, how to create multi-container architecture in Docker. So how to create multiple containers and how to establish a connection between them. So that is what we are learning. So what are the two methods we have told for this one? For multi-container architecture, we have discussed two methods, right? There are two methods. In two methods, by using two methods, we can create multi-container architecture. What are the two methods we have discussed in the previous class? One is -- link option. Other one is Docker Compose. Hope my voice is fine. Is it good? Shall I continue?
Yeah.
You're audible. I'm audible, right? Yes. So, I already told you that -- link option. We already discussed about -- link option. Now we are talking about Docker Compose. And we gave some introduction part about Docker Compose also. This is a feature which is used for creating multi-container architecture, but using YAML file. Previous method is creating multi-container architecture by using -- link method. Here we are creating multi-container architecture using YAML file. So what does the YAML file contains? YAML file contains the information about the containers. We are going to write the information in the YAML file. We are going to give the information in the YAML file. How can we create content? What are the containers we are going to create, and how can we establish a link? How can we establish link between them? So entire information we will be giving in YAML file. So how the YAML file looks like, I told you already. YAML is not a file. YAML is a file format. YAML is not a scripting language. YAML is just a file format. It is not a scripting language. So how we will write input in the YAML, how we will give input in the YAML. Left hand side, always keys will be there. Right hand side, values will be there. And YAML file is space indented. YAML file is space indented. Okay. So we have to, the meaning of space indented means we have to follow the correct format of space. We have to give correct spaces and we have to follow particular syntax. Then only we can able to execute this YAML file. I already told you that this is an example file. Okay, this is an example file we are discussing about. Suppose here what we have, we are taking this one as Kingdomtrainings. So under Kingdomtrainings, we have child elements called trainers and coordinators. So like that, again, under trainers, we have given one space. You see, there is one space indentation between trainers and between the key value between this one. Okay. So this particular root element, this is now trainers is called parent element. Anyhow, the first one is always called as a root element. Why? Because there is no parent for this. There is no parent for this element. That is why it is called as root element. Okay. The remaining things are the next one is called parent element. Why it is called as parent element? Why? Because it is having two children. We are able to see clearly. It is having two children. Coordinator is also having two children. So coordinator is parent element. Then we will consider we will consider both trainers and coordinators as siblings. Okay, both trainers and coordinators are siblings. Why? Because both are maintained at only one space. Both are given at only one space. That's why trainers and coordinators that comes under the children of Kingdomtrainings. Trainers and coordinators, they comes under the child elements of K-trainings. So like that, we need to assume left hand side, we need to provide keys. Right hand side, we need to provide values. Okay. In this way, we are going to write an YAML file. So we are already told you how to install Docker Compose and all. We have two commands here. We can execute these two commands so that we can install Docker Compose. To check the Docker Compose, whether the Docker Compose is installed or not, we can even we can go for verifying it by using a command called docker compose -- version. You see here we have already verified. Let me clear the screen and let me show you whether Docker Compose is installed or not. To verify Docker Compose is installed or not, we will give a command called docker compose -- version. so that we can understand whether the Docker Compose is installed or not. Yes, Docker Compose is installed. Make sure you install Docker before you install Docker Compose. If Docker is not available, Docker Compose will not be installed. You have to install Docker. Anyhow, we will install Docker. That's fine. But make sure you should have installed Docker. Suppose if you want to install Docker Compose. And what is the purpose of Docker Compose? I told you, creating a multi-container architecture. Now let me execute one example here. How we are going to save the file? We are going to save the file with the help of this one. Okay, vim space docker compose.ml. This is how we need to save the file. Docker compose.ml. Vim space docker hyphen compose.ml. So now what happens if file is not there? If there is no file called docker compose, new file will be created. You see, docker compose.ml, new file is created, and we have to pass the content inside it. We have to give it inside it. We have to give the content inside it. I'm just copying this one, whatever the YAML file we have discussed in the previous classes. You all know the meaning of this YAML file. You all know the meaning of YAML file. You see, services is the root element, and dev server is the container. QA server is another container. Prod server is another container. Services, QA services is the root element. Dev server is the parent one container. QA server is another container. Prod server is another container. 3 containers we are creating. So the container information we are providing here. What is the content? How we are creating container? Suppose if we want to create container, definitely we should mention the image name, from which image we are creating container. So this dev server container is being created from the image called Jenkins/Jenkins. Then what is the port number we are assigning to it? We are assigning the port number called 7070. Then next one, QA server. What about QA server? It is a second container we are creating by using the image called Tommy. Port number we are assigning is 88899. And the links, how we are linking? We are linking this QA server. We are linking this QA server with the Jenkins, with the dev server. How we are linking, you can see. We are linking this with the dev server. Links, where dev server : Jenkins. This name you can give anything, but we are linking. Under links option, you have to provide which server you are going to link, or which container you are going to link. So I'm going to link the dev server container. That's why I'm providing the name of the dev server. This is your name, alias name. You can provide some name to this one. Okay. It is your wish. You can provide any name here. But here you have to provide the container name, which container you are going to link. So then third container is prod server. The third one is prod server. What is the image name? We are using Tommy only. Okay, for QA server as well as prod server, we are using Tommy only. What are the port numbers we are assigning? 9090 is the port we are assigning. Link. See, in the link you can observe clearly, we are linking the first container called dev server. Okay, we are linking the dev server with the second QA server. Similarly, we are also linking the dev server with the prod server. Okay, try to understand here. Link in the sense here, we are using this option to link some server, to link some container. Which container I am linking to this particular container? 3 containers are there. This is the first container. Dev server is the first container. QA server is the second container. Prod server is the third container. I am going to link. Since this is the first container, we cannot link with anyone. Since this is the first container, we cannot link with anyone. Why? Because there are no pre-existing containers. So that's why while creating the second container, or otherwise once the second container is created, we can link the first container with the second container. Okay. Now what happens? This is the third container. Even we can link the second container with the third container. The first 2 containers here, we can link the first 2 containers. Okay. Like the dev server, we can link. Similarly, QA server also we can link. But here what we are doing, we are just linking the dev server. Let's see the output. Okay. How to save the file? Escape, shift : WQ. So how to execute the Docker file? Whenever you are writing a Docker compose file, how to execute it? You have to give a command called docker compose up-d. We have to use a command called docker compose up-d. What is showing? Could not connect to Docker daemon and HTTP Docker localhost. Let me verify whether the Docker is installed or not. Yeah, both Docker is installed as well as Docker version is also installed. Whenever we are executing some command, it is showing some error. Docker compose sub -d. Let me do it in another way. Because of some configuration issues, we are not able to run Docker compose. Okay. So let me try with some other operating system. Okay, there are some configuration issues in Amazon Linux. That's why it is not the Docker Compose is not getting up. So let me try with other operating system. I have selected an operating system called Ubuntu. Okay, just now I have created a machine with an operating system called Ubuntu. Let's try. Let's try with this. Okay, whether we can able to see whether we can able to run Docker Compose here or not. So let this machine. Let's wait for the machine to come into the running state. Yeah, this machine came to the running state, and let me connect to the system. You see, this is altogether a new machine. That's why I'm installing Docker. How to install Docker? We know the very basic command: sudo yum install Docker. You can use a command called sudo yum install Docker. I think yum is not a keyword here. We cannot. Yum is not a repository. We cannot use yum. So that's why I'm using apt sudo apt install Docker. Okay, since it is a Ubuntu, so I think we cannot use this one. That's why. So if see, usually we will try installing like this, but in some operating systems, if it is not installed, I told you, right, you can go to website. What is the website? I told you, get.docker.com. Please go to the website called get.docker.com. If the package is not available in the M repository or apt repository, then you can go there and you can download the package. We are downloading a package, you can see. And how to run the package: sh space get-docker.sh, so that the Docker will be installed. Once the Docker is installed, we can go for Docker Compose. So let me check the Docker version, Docker space -- version. Okay, Docker is installed. Now, how to install Docker Compose? First, you can try with a command called sudo apt install Docker Compose. Okay, you can install by using a command called sudo apt install Docker Compose. If it is not installed, then you can go for commands under. Anyhow, it is taking. Okay, so if it is taking, if the package is available, it is fine. That will get installed. The package is not available. I already told you how to go. How we have commands. We need to run those commands so that the Docker will be that will get installed. Okay. sec, I think. Docker. It is not. Anyhow, it is showing Docker Compose 1.29.2 is installed. So let me run how to save a file. We have all seen that. vim space docker compose.yaml. This is how we will save a file. So I'm giving this YAML file here. I'm saving the contents. Shift:WQ. How to save the contents? We know in the VI editor how to save the contents. Shift:WQ. So how to run this YAML file now? Whatever the YAML file we have provided, whatever the YAML contents we have saved, how to run the YAML file? So we have a command called docker compose up -d, so that it will start actually. See, whenever what I'm doing. The first container, it is trying to pull the dev server. First, it is trying to pull the dev server. So what is the image name we are using? Jenkins/Jenkins. Jenkins/Jenkins is not available. This image is not available locally. If the image is not available locally, it will pull from Docker Hub. It will pull from Docker Hub. It is downloaded, and it is running that as a container. Okay. Again, the second one is Tommy. Okay, third is also Tommy. And you see, if the image is not available, second image Tommy image is not available locally, it is downloading. See, for the third time also we are using Tommy image, but it is not getting downloaded. Why? Can you tell me why for the third time the Tommy image is not getting downloaded? Why? Because Tommy image is already available locally. Okay. See, for the second container, we are downloading Tommy image. So Tommy image is getting downloaded. So what is the third container we have given? We have given the third container as prod server, but the image is Tommy only. So Tommy image is already available, right? That's why it is not getting downloaded. Anyhow, 3 containers got created. 3 containers got created, and we know that how the communication will also it is a multi-container architecture. We have created multiple containers, and multiple containers got connected with each other. All the 3 multiple containers got connected with each other. So you can verify the output. You can verify the containers here by accessing the containers. You can access the containers. How can we access? We know the public IP of the server. You take the public IP of the server, go to instances, click on the instances. This is the public IP of the server. So we know that before we do that, we need to add some inbound rules. Click on inbound rules. Go to security groups, edit inbound rules. Okay, we are adding some other port number that is called, we're allowing all the port numbers. Okay, that's why I'm giving all traffic. Anyway, I'm saving the rules. Now you can copy the public IP of that server, go to the instances, copy the public IP of the server. This is the public IP of the server. You can go there. Now you can check with the port numbers. What is the port number? The same IP address, but port numbers are different. We have assigned different port numbers. For Jenkins, we have assigned the port number called 7070. Let us check whether we are able to access Jenkins with this port number called 7070. Yes, we were able to access Jenkins by using 7070. Okay. Similarly, the next port number is 8899. Okay, 8899. So we will check whether we are able to access. Okay. So anyhow, the same IP address. Same IP address, colon, 8899. We are able to access Tomcat. Okay, this is called QA server. Okay, dev server, QA server, and prod server. 3 types of containers we have created. Dev server is Jenkins. QA server is Tomcat. And one more server I would like to create. I have given, that is called another Tomcat server. The port number is 9090. Okay, port number is 9090. So again, I'm going to copy the same IP address. Okay, again, I'm going to copy the same IP address. (9090) is the port number we have assigned. So we are able to access all the 3 containers. We were able to access all the 3 containers. Okay, and these 3 containers were in the communication. Now, if you want to create multi-container architecture, you will understand slowly what is the purpose of multi-container architecture. I already discussed with you that whenever we are creating a container, so Docker container is running isolated. It is running isolated. That means it is not depending on the operating system. So what happens? It is a lightweight process. This container is a lightweight process. It is running as one OS program. It is not depending on the OS. So that's why it will not utilize the resources continuously. So whatever the container here it is running, this container is not going to utilize our hardware resources continuously. Whenever the container is running, that time only it will utilize the services. It will utilize the hardware of our computer. Whenever the container is not running, it will not utilize. Okay, whenever the container is not running, it will not utilize. Only whenever the containers are running, then only the hardware will be utilized by these containers. So I told you that the difference between virtualization and containerization. In the virtualization, though you use the application or not, though you run the application or not, once you install the application, it will utilize some hardware. Okay, here container is not like that. Container will not utilize your hardware. Container will utilize the hardware. Container will utilize your CPU and hardware only whenever you run this container. So anyhow, we know how to create multi-container, or we know how to create multiple containers. Okay, and how to link multiple containers. We have linked 3 containers. And what is the advantage of linking multiple containers? You will understand slowly. Okay, we'll understand slowly what is the advantage of linking multiple containers each other. So what happens is the communication will take place between them. I already told you. So when we link, we have linked 2 containers by using ---- link option. I told you whenever I am pinging the second container, or whenever I'm pinging the first container from the second container, we are able to see the output. That means both the containers are in communication. Like that, we have created 3 containers, and all the 3 containers are running now. All the 3 containers are linked to each other. So internal communication is taking place between these containers. You'll understand how actually we will use it in real time slowly. So this is the Docker Compose. This is how we use Docker Compose for creating multi-container architecture. Very important thing. Suppose if someone asks you, do you know how to create multi-container architecture? Yes, we know how to create multi-container. We know how to create multiple containers and linking multiple containers. Multi-container architecture in Docker can be created by using 2 ways. One is ---- link method. Other one is what? Docker Compose. So by using Docker Compose, we are going to create multiple containers by using YAML file. With the help of YAML file, we are going to do it. Okay. Another way is ---- link option. Just by using ---- link, we can do it. In other way, just by writing YAML file, we can do it. So in both the ways you can do it. Let me start the another one, which is called as Docker volumes. Try to understand what is a Docker volume. Docker volumes are ephemeral. Docker volumes, we are talking about a concept called Docker volumes. Try to understand what is Docker volume. So Docker containers are ephemeral. Whatever the Docker containers we are creating, they are ephemeral. They are temporary only. They will not be there permanently. Okay. So today you may create one container. Today we may create one container, and tomorrow we may delete that container. That's why Docker containers are ephemeral. Ephemeral in the sense, the meaning of ephemeral is temporary. We may create Docker containers and we may delete them. Whereas the data processed by the container should be permanent. Whatever the data that is processed by the container, that should be permanent. So what is happening now, generally, when a container is deleted, all the data will also be lost. When we delete a container now, all its data will also be lost. That should not happen, right? That should not happen. Though the container is deleted, we should have the data. We should have the data that is related to the container. So the main object of Docker volume is to preserve the data even after deleting the container. Even after deleting the container, we need to preserve the data of that container. That's fine. You may delete the container. You may create one container today. You may delete it. Okay, you consider you work with some container for 10 days. Then you can go for deleting that container. You may create some other new container, whatever it is that might happen. But the data should be permanent. Container is ephemeral. We are talking about Docker containers. They are ephemeral. They're temporary only. Container may stop. We may stop the container. We may start the container. We may delete the container. We may create a new container. They are ephemeral. They are temporary. But the data should be whatever the data we are using. That data should be available for us. So Docker containers are ephemeral generally. When a container is deleted, all of its data will also be lost. We will lose all the data when a container is deleted. That should not happen. So to preserve the data, to save the data, even after deleting the container, to preserve the data even after deleting the container, we use the concept of volumes. We use the concept called Docker volumes. Docker volumes are of two types. One is simple Docker volume, other one is shareable volumes. There are two types of volumes, simple volumes and shareable volumes. The shareable volumes is also called as Docker shareable volume, Docker shareable or otherwise Docker volume containers. First one is, see, how can you remember? This is also very important thing. Docker volume. What are the two types of Docker volumes? We have two types of Docker volumes. One is simple volumes, other one is shareable volumes. We will talk about simple volumes first, then we'll go for shareable volumes. I'm going to show you what is simple Docker volume. Try to understand what is simple Docker volume. These volumes are used only when we want to access the data, even after the container is deleted. Try to understand this point. Even after the container is deleted, suppose if a container is deleted, the data inside the container will also be lost. But we don't want that data. We don't want to lose that data inside the container. So what we are doing, the volumes are used, simple volumes are used only when we want to access the data, even after the container is deleted. But this data cannot be shared with other containers. This point we will discuss later. But anyhow, even after the container is deleted, if we want to have the data, we can go for simple Docker volumes. Let me see what we are going to do first. We are going to create a directory called /data. Okay, we are going to create a folder. We are going to create a directory called /data. Let me see here. So how to create a folder? We know that mkdir, with the help of mkdir. So try to observe carefully what I am doing. I am just creating a container. I'm just creating a folder. That's it. mkdir/data. Okay. You can see here. I'm just clearing the screen. What we are doing, we're just clear. We have created one folder called data/data. Okay. If you want to see that, you can see. How can we see that? I think we are a root user now. You see here by giving ls data. Okay. So what is the folder we have created? Can you tell me? The folder we have created is what? Data. We have created a folder called data. Try to understand. We have created a folder. If you want to see that folder, you have to go back to the home location, then you can see. Okay. So I'm just exiting sudo su -. I'm going here. So once you create a folder, once you create a folder with slash, once you create a folder or once you create a directory with slash, you cannot see that one here. You cannot see that one here. We have already created that. But whenever we are giving ls command, we are unable to see it here. If you want to see it, please go back to the home location just by giving cd space double dot. If you give cd space double dot, then you can give ls command there. All the files are available. Our data directory, the directory we have created this directory called data. Okay. So that is an empty directory. I think we don't have any files. That is an empty directory. Even you can go inside the data directory. We can go inside that cd space data, and you can give an ls command. Okay, that is an empty one. I'm coming back. Okay, I'm coming back, and I'm going as a root user. If you have any doubts, you can just exit. Okay, exit, and you can go like you can enter like sudo su - also. So now we are the root user, and you see, you observe carefully what I'm going to run. I'm going to run a command called docker run. I'm going to run a command called docker run. What is the image name I'm using? This is docker run. Okay, docker run. What is this one? This one is called CentOS. CentOS is the image name. This is the image I'm using. And whenever I'm using an image, it will become a container, right? By using docker run command, what happens? Docker run some image name. If I use docker run command and if I specify some image name, container will be created. What is the name of the container I'm providing? We know the name of the container we are providing is -, name. The syntax I'm giving is -, name. Name of the container is C1. We are creating a container. We are creating, or we are providing the name of container as C1. We know what is -it. -it stands for interactive terminal. -it stands for interactive terminal. What about this one -v? -v is for attaching volume. -v is for attaching volume. We are going to attach a volume. What is the volume we are attaching? We have created /data, right? We have created a folder called /data. We have created a folder called /data. We are going to attach that /data folder to this particular container. -v/data. This is the directory I'm using. This is the directory I have attached. -v/data. That means I am attaching this /data folder to this particular container called C1. So -v option is used for attaching volume. I am running this command. Copy this, paste it over here. What happens? So image is not there. So it is pulling the image. Once the image is downloaded, it will run the container. Name of the container is C1. We have provided -it option. We know what happens if I provide -it. We will go inside the container. Okay. We will go inside the container. You see here. Previously, we were there at the operating system level. Whenever I am running the command, I was at operating system level. It is showing some IP address. Now it is showing some ID container ID. It is showing some container ID. Okay, so I have attached some volume also. Okay, now you can provide ls command. So if you provide ls command, you can see the data folder also. You can also see the data folder also. You provide ls command here. Can you able to see the data folder here? We have attached the data folder, right? We have attached the data folder, right? You can able to see the data folder inside the container. It's fine. Okay. Now I am going to create some files. I'm going to create some empty files here. Okay. So how to create empty files? You can go inside the directory by giving cd space data. You can create some empty files. You can, if you want to see, you can see them, and just give a command called exit. Okay. So what I am doing, I'm going inside the directory called data, cd space data. And I'm going to create some files here, touch space file 1, file 2, two files, two empty files I'm creating. You can give ls command to see the list of files. You understood, right? I have attached a volume called data and I'm storing some data, file 1, file 2 data I'm storing. So after saving some files, I'm just exiting from the container. To come out of the container, you just give exit. Okay. To come out of the container, just give exit. Once you exit, we came back to the operating system level. Then we are going to use one command. This is the we are going to use one more command called docker inspect. What is the purpose of docker inspect? I'll tell you, okay? If you give this command called docker inspect, you can see some information about the container C1. When I'm giving docker inspect C1, I'm able to see some information, okay? Some information about the container. So here you can able to see one folder, you can able to see one section called mount. See, it is displaying some information, right? You can able to see one structure called mount. Yeah, you can able to see one thing called mount. Under mount, you can able to see this file path. Okay, so this is the source. This is the path we have to save. I'm copying it. And I'm going to paste it. You see where I'm pasting. You see, I have saved the path from here, /var/lib. Okay, this is the path we have to save. Then after saving this particular path, let's delete the container. We don't want that container. Suppose if we don't want that container, we can delete the container. How can we delete the container? We can delete the container by using a command called docker rm docker remove. -f stands for by force. I'm going to remove the container by force. Removing the container by force. So I can use this particular command, docker remove -f. Docker remove -f c1. I'm copying this command. I'm going to paste this command over here so that the container will be deleted now. Your container will be deleted. C1 container will be deleted. We don't have any containers. Even if you want to see, you can check docker container ls. Other command is also there. Sorry, spelling mistake. You see, we don't have, we have containers, but we don't have that particular container called C1. We don't have that particular container called C1. We have deleted the C1 container. Even you can see docker ps-a. C1 container will not be there. We have two Tommy containers and we have one Jenkins container. That's it. We don't have that C1 container. What is the C1 container we have taken? That is CentOS. That is CentOS image. With the help of CentOS image, we created that. So what we would like to see here is, even after deleting the container, the data should be there. We have deleted the container, right? Even after deleting the container, you can go to the location of the data folder. You can go to the location of the data folder and you can check that particular location by giving cd space, the particular location. We have saved here, right? See, this is the location. Okay, if you want to see whether the data is still there or not, you can go there. You can give a command called cd space, that particular location name. This is the location we have saved. You can give enter. Just give ls command and you can able to see the files here, file 1 and file 2, which we have saved. The container is not there. Try to understand. The container is not there, but even after deleting the container, we are able to see the files. Even after deleting the container, we can able to see the files. That is the concept of Docker volume. By the name itself, it is indicating volume. Volume is nothing but storage. If we want to store any data inside the container, we can store. But actually what happens whenever we delete the container, the data will be stored. The data will also be lost, right? If we store some data inside the container, whenever I delete the container, the data will also be lost. So, but what happens, what we are doing, that should not happen. We are preserving the data. Even after deleting the container, we are preserving the data. How we are preserving the data? We are just creating a directory and we are attaching directory and we are attaching that directory to the volume. We are attaching that directory to the container. Okay, we are attaching that directory to the container and we are saving the data so that we are mounting that path. We are mounting that path. So we are storing this particular data folder in the operating system level. In the operating system level, we are storing that. So what happens whenever we are working with the container, we can store the data in that particular folder. But even if you delete the container, we don't have any problem. Why? Because that is mounted with our operating system. Whenever you want to access the data, you can access it. That is the idea of Docker volume. So what is the concept we have discussed so far? Whether we have discussed about Docker volume, whether we have discussed about simple volumes or shareable volumes. So far, we have seen the concept of simple volumes you see here. Let me tell you once again. So volumes are of two types. What is the main object of Docker volume? Docker containers are ephemeral. That means whatever the containers we are creating, whatever the Docker containers we are creating, they are temporary. So generally whenever a container is deleted, all of its data will be lost. Okay, whenever a container is deleted, all of its data will be lost. So we are not making that happen. We are not making it to happen. What we are doing, we are preserving the data. Even after deleting the container, we should preserve the data. That is the purpose why we are using the concept called Docker volumes. There are two types of Docker volumes. One is simple volumes, other one is Docker shareable volumes. Simple volumes and shareable volumes. Simple volumes means what? We are just attaching a volume to the container. We are creating a directory called /data and we are attaching this /data folder to your container. You can attach. You see how we are attaching. We are going to run an image called CentOS and we are providing some name to the container called C1-IT, to interact with the particular container. -v option, by using -v option. Suppose if someone asks you, how can you attach a volume to the Docker container? By using -v option. By using -v, we can attach Docker, we can attach a volume. So we are attaching this particular folder. So I'm moving inside the folder, I'm creating some files. Okay, after attaching a volume, I am moving inside the folder, I'm creating some files. I'm exiting. And if to preserve the data, what I'm doing, see, even after deleting the container, if I want to access the data, you need that path, you need that mount path. So to know the mount path, you have to give a command called docker inspect C1. Please give a command called docker inspect C1 so that you will find one section called mounts. Under mounts, it will show some path like this, where lib docker volumes like that. Please copy the path. I have copied the path like here. Okay. These are the previous ones I've deleted. Okay. I'm deleting. So like this, you have the path, you copy the path, and you can delete the container now. If you have this mount path, you don't need to worry about the container, you can delete the container. Though the container is deleted, if you can delete the container, you are able to access the volume. You can able to access the volume. This command is for deleting the container. Docker remove -f C1. We are forcibly removing the container called C1. We are removing this container. After deleting the container, you can go to the particular location of the data folder. That means we have copied one path, right? Mount path. You can go to that particular location by giving cd command. cd command use chesi a particular location ki velte, you can see by using ls command. ls command choose me kanipistayi anamata files. Avm files మనం సేవ్ చేస్తాం. You understood, right? You can observe that the container is deleted, but still data is persistent. We are preserving the data even though the container is deleted. Then we have one more concept called shareable volumes. We are talking about shareable volumes. I told you there are two volumes are there, simple and shareable. I'm now going to talk about shareable volumes, you see. What we're doing here is here also same thing we're doing. We are creating a folder called /data. And we are going to run a command. This one you see, docker run. Image name is CentOS. -- name C1 option I'm using. C1 container. I'm providing the name to the CentOS as C1. -IT stands for interactive terminal. -v/data means we are attaching data folder to the, we are attaching a directory called data to the particular container called C1. C1 అనే కంటైనర్ కి, ఈ C1 అనే కంటైనర్ కి మనం ఈ వాల్యూమ్ అటాచ్ చేస్తున్నాం. డేటా అనే వాల్యూమ్ మనం అటాచ్ చేస్తున్నాం చూడండి. Okay. So by using ls command, you can see the list of files and directories in the CentOS. There you can find this data folder also. Okay, if you want to provide some data inside the data, if you want to store some data, you can go there. You can create some files. Okay. Usually an empty directory we are attaching. If you want to provide some data, you can go inside the data. You can give ls command. It will show that currently we don't have any files. It will not show any files. If you want to create some files, you can create by using file1 and file2. Touch space file1, file2. Then to come out of the container, I was telling you, to come out of the container without exit, you can run a command called control+p+q. Okay, you can give a command called control+p+q, or otherwise control plus. Simply you can give control+p+q so that you can come out of the container without exit. Container will be running in the background. Now you see the second one, so that we will understand the idea of shareable volumes. Docker run, same CentOS image. Name of the container?
C2.
What? C2. Name of the container is C2. Here also we are providing -IT option to interact with the container. Here we are using some other option called --volumes from space C1. C1 is the first container. C1 is the name of the first container. --volumes -from. This is the keyword we are using. The purpose is we are not creating multiple containers. We are not creating multiple volumes. We are not creating multiple volumes. We are creating a single volume. Okay. And what is the name of the volume we have created? Do you remember? What is the name of the volume we have created?
Data,
/data. This is the volume we have created. The same volume we are using for the same volume we are attached. We have attached the same volume for first container, and the same volume we are going to use for the second container also. That is why it is called a shareable volume. We are going to see, we are not attaching another volume here. What we are doing, whenever you are creating another container called C2, we are just using the volume of C1. How to use the volume of C1? --volumes -from. --volumes -from C1 option. --volumes -from space C1. C1 is the first container. So whatever the volume that is there with the C1, we are going to use the volume of that C1. Okay. Then here also you can do like, you can go for, you can go to the data, you can give some files. You can create some more files. Okay. You can create some more files, and you can delete both the containers. If you want to create one more container, you can create. If you want to create one more container, you can create. And you see what we are doing, we are going to use the volume of C2. Now we are using the volume of C2. We can see if you provide ls command here itself, you can see the files created by C1. You understood, right? The same file, the same volume we are using for multiple containers. Let's see what we are doing. I am going to create a folder called /data. I think the /data is already there. I'm just coming back. Exit sudo su-. So to check whether that data folder is there. Yes, data is already, this data folder is already there. Data directory is already there. We have created. Okay, that is there already. So what we are doing, we don't need to create again. And now we are going for the second one. What is the second container? How we are providing the second one? You see, Let's try by deleting that one. You can delete that one, okay? You can delete that one by using, how can we delete a directory? rm space, rmdir, directory name.
rm space directory name.
Yeah. So you can see that data folder is not there. Data folder is not there, okay? I'm starting with once again. I'm going to create once again sudo su hyphen. So here I'm going to create a directory called mkdir/data folder. I've created a folder called data, and I'm going to run. You see here, I have created a folder called data. Now I'm going to run the CentOS as a container. So this is the first container I'm creating. Okay. I'm just copying it. You know the meaning of this command, right? Meaning of this command is I'm creating C1 container. I'm attaching the volume of /data. Okay. Yes, I have attached a volume called /data. Now let's see. You can see ls command. You can give ls command and you can see. Use ls command and you can see. You can see the folder of data here. If you want to go inside the data folder, you can go cd space data. Just give ls command over there. No files are there. If you want to create, you can create files. Touch space file1 space file2. I'm creating 2 files. By giving ls command, you can see file1 and file2 are there. Okay. So that's fine. We have created files. After creating files, you can come out of the container without exit. Please come out of the container without exit. How to come out of the container? You see Control plus P plus Q. Okay, you can give a command called Control plus P plus Q. We will come out of the container. Yes, I came out of the container. Now what I am doing, I am going to, container is running in the background. Okay, don't think that we have exited the container. We have exited from the container. Container is running in the background. Let's start another container. So we are going to start another container. So try to understand what is the keyword we are using. Hyphen volumes from the, so Docker run. We are going to create one more container called C2 -IT for interactive terminal. Hyphen volumes from C1. Whatever the volume that is created for C1, it is also going to use, container 2 is also going to use the same volume. We are attaching the same volume. Okay. Let's see. And you can see here ls command. You are also able to see the folder called data. You can go inside the data, ls command. We have 2 files. Can you able to see 2 files? And if you want to create 2 more files here, you can create. I am creating file 3, file 4. You can give ls command. Totally 4 files are there. For the first container, we have attached 2 files. So in the second container, while after attaching to the second container, we have created another 2 files. So again, what you can see is, if you want to come out of the container, we can use a command called Control plus P plus Q. Control P plus Q. We came out of the container. Okay, still the container is running. Both the containers are running in the background. So like that, you can create container. You can create any number of containers like that. You can see. But what I have told you, before you delete all the containers, you have to go to the mount location. Go to the mount location. How to identify the mount location? By using a command called, how to go to the mount location? Docker inspect C1. Go to the mount location, and there you will find a path called mount path. From here you have to copy the mount path. Okay, I'm just saving here. I'm deleting the previous one. Okay, deleting the previous one. This is the mount path I'm having. Now you can delete all the containers. You can delete all the containers. We don't need to worry about the containers and all. You can delete all the containers. You see, let's remove all the containers. How I'm removing? Docker rm -f c1 c2. We have created only 2 containers, right? I am going to delete both the containers. See, Docker rm -f c1 c2. Both c1 and c2 will get deleted. Now you see, we don't have any containers. You can see by using Docker ps-a, whatever it is. You don't have that c1 c2 containers. So even though the containers are not there, you can still able to access the data by using mount path. You can go to the mount path where we have saved the data. You understood, right? We have just now we have saved the mount path, I think. This one. Copy. You can go here, cd space, the particular mount path. Give ls command over there, and you can able to see all the 4 files. Okay, though the containers are deleted, we can preserve the data, but what we should have is, we should have the mount path. So where we can find the mount path, please go to the, please give a command called docker inspect c1, so that it will give you some mount path. Please copy the mount path. So if you have the mount path, you will be having the data. You can able to access the data, though you have the container or not. So this is the idea of Docker container. There are 2 types of containers: simple or shareable. That means if I attach only a single, if I attach a volume to a container, that is called normal Docker, simple volume concept. What is shareable volume? If a single volume is being shared by multiple containers. If a single volume is being shared by multiple containers, that is the idea of shareable volumes. Okay, we will create a single volume, and the same volume will be used for sharing, for storing the data of all the containers. So that is called shareable volumes. You can store multiple data, multiple containers volume there. That's fine. If you have any doubts, please let me know. Otherwise, we'll close it for today. So Docker, we discussed about volumes, Docker volumes. So tomorrow we'll see another concept called we will see in the tomorrow session, we will see how to create our customized Docker images. Okay, how can we create our own images? How can we create our own Docker images? We'll discuss tomorrow. Once it is done, we will go for discussing Kubernetes. Okay, we'll start Kubernetes. So yes, please let me know if you have any doubts.
హలో
Yes.
వంశీ ఇది ఈజీ టు కనెక్ట్ అవ్వట్లేదు, అది ఎట్లా? అది ఈజీ టు టెర్మినల్ కనెక్ట్.
Yeah, there is some conflict. See, what you can do is, suppose if you are not able to connect, okay, suppose if you are not able to connect, usually what you are doing, you are creating some EC2 instance.
Yes.
Okay.
Okay.
And usually there are some configuration change. There need to be some configuration changes in your local system. Suppose if you are not able to, if you are not able to connect with that system, even after many trials, better you go with Git bash terminal. I told you that Git bash terminal, Git bash.
Yes,
You can
yes.
connect like that. But anyhow, please try here. Whenever you create an instance, I told you, please try to open the port number. I told you, right, in the security groups.
Okay,
Go to
okay.
security groups. Okay, immediately after creating the instance, if you are not able to connect with that, usually how we are connecting after creating the instance, we are going here like this, selecting the particular instance. We will click on connect button, right? We click
Yes.
on connect button, and we are coming here and we are just selecting this connect button.
Yes.
So that we are able to connect. We are connecting to the machine now. So suppose if you are not able to connect, then what can you do is,
Okay.
so please go there. Okay, go to instances. So click on the instance ID. Go to the security groups. Go to the security groups.
Okay.
And there you can edit the rules. You can please open the port numbers. Okay, open the port numbers. You open all traffic. Okay, you open all
Okay.
traffic and try again.
Okay, okay.
Still if the problem persists, okay, still if you are facing the problem, better you connect with the Git bash terminal. Why? Because that is the issue. Some maybe some firewalls are blocking your computer to connect. Okay, so you better you go with the option called Git bash, and you please practice. And in the YouTube, you can go to the YouTube and you can find many videos. Okay, how can we block firewalls, unblock, how can we unblock firewalls, and how can we connect with our EC2 instances and all. So anyhow, if you are able to connect to this instance simply, you can connect.
Okay.
Otherwise, try changing security groups.
Okay.
Try modifying the security groups. Still, if you are not able to connect, then please go for connecting with Git bash without wasting time. And if you want to solve that issue, please go to the YouTube. Okay, there will be many videos. They'll be explaining how to unblock the firewalls so that you can able to connect it. Okay.
Okay. Thank you.
Yeah. Thank you all. If you have any doubts still, please tell. That's it. We'll meet tomorrow for the next session.